Hello, Professor. My name is Ali Manoj Kumar, CWID 50302894. Uh, I've, I've done this project individually. Yeah. Um, the outline of this project is designing a C++ program to simulate an airport, also the landing and departure of flights on a runway. Inside, airport has one runway, single runway services, both landing and departure. Only one services runs at a time, either to land or depart. We are going to implement an simulator using threads and semaphores. Here, our program will have main process, plane creation, arrival service, and departure service. Before going into our program, let's learn about the methods we have used in this one, multi-threading and semaphore. Multi-threading. Multithreading is the ability of program or an operating system to enable more than one user at a time without requiring multiple copies of the program running on the computer. Multithreading can also handle multiple requests from the same user. Each user request for a program or a system service is tracked as a thread with a separate identity. As program works on behalf of the initial thread request and are interrupted by other requests, the work status of the initial request is tracked until the work is completed. In this context, the user can also be another program. How multithreading works. The extremely fast processing speeds of today's microprocessors make multithreading possible. Even though the processor executes only one instruction at a time, threads from multiple programs are executed so fast that it appears multiple programs are executing concurrently. Even the CPU cycle executes a single thread that links to all the other threads in this stream. This synchronization process occurs so quickly that it appears all the streams are executing at the same time. This can be described as a multi-threaded program, as it can execute many threads while processing. Each thread contains information about how it relates to the overall program. While in the asynchronous processing stream, some threads are executed while others wait for their turn. Multithreading requires programmers to pay careful attention to prevent race conditions and deadlock. Semaphores. Semaphores are integer variables that are used to solve critical section problem by using two atomic operations, wait and signal, that are used for process synchronization. The definitions of wait and signal are as follows. The wait operation decrements the value of its argument S if it is positive. If S is negative or zero, then no operation is performed. Signal. The signal operation increments the value of its argument S. There are two types of semaphore, counting semaphore and binary semaphore. These are integer value semaphores and have an unrestricted value domain. These semaphores are used to coordinate the resource access, where the semaphore count is the number of variable resource. If the resources are added, semaphore count automatically incremented, and if the resources are removed, the count is decremented. Binary semaphores. The binary semaphores are like counting semaphores, but their value is restricted to 0 and 1. The wait operation only works when the semaphore is 1, and the signal operation succeeds when the semaphore is 0. It is sometimes easier to implement binary semaphores than counting semaphores. Yeah. Now let's look at our program. Yeah, this is my program. Uh, yeah. In this code, I have used thread and semaphore libraries. I have created three threads like create, lane, serving, departure, and serving arrival threads. So when the create lane thread executes, it sleeps for some random time, and by using a random function, it will choose whether to choose arrival service or departure service. If the random function chooses one, then the arrival function will be executed and a new plane will be pushed into the arrival queue. If the random function chooses departure queue, plane created will be pushed into departure queue. When the simulation starts, these three threads are executes concurrently, so there will be mutual exclusion issue. In order to solve this issue, I have used a semaphore. As we have discussed, semaphores are integer variables that are used to solve critical section problem by using two atomic operations, wait and signal, that are used for process synchronization. Um, here semaphore runway is created and initialized with 1 so that the semaphore accepts only one process at a time. When the thread serving departure executes, it first sleeps for some time, and when this departure queue is empty, it calls a function, check runway, which is a semaphore function. So in the runway function, the stem wait instruction is used, which will accept one process and enters the process into a critical section. In the critical section, the first element from the queue is pulled and the statistics are printed. Once the execution is completed, the process comes out of the critical section and the same post instruction is executed, which allows the other process waiting in the queue to the critical section. Let's now run the code and check the output. So here we can see that flight D1 has so here we can see that the flight D1 has been deported so that the statistics in the plane service is showing 1 in the departure service as there are uh, no flights in the arrival service. It is showing 0 and as of now there are no flights in the waiting queue. When we run it again, yeah, when we run it again, the arrival thread has been chosen and the arrival service is executed. So the A1 flight arrived is shown in the statistics. Still there are no flights waiting in the queue. It is showing 0. So it is showing 0. So if you run it again, we can see that flight D2 has been reported. So the statistics in the plane it is showing as 2 in the departure service. As there is a run it again. Yeah, now we can see the flight T3 has been reported. So the statistics in the plane service showing as number 3. Yeah, yeah. So then we choose to stop simulation. Yeah. This is how my code works. Thank you, Professor.